Hey everybody, what's cracking? How's everybody doing? Hope everybody's doing good, Hope everybody's safe through all those storms and stuff yesterday. I'll talk a little bit more about that here in a minute. It actually affected why I didn't do a stream last night. Yeah. So, somebody give me a 5 for 5 and we'll go. We will get this thing rolling, as they say. Are we good, guys? 5 for 5? Sweet. Okay. Please share it out, guys. I will say that. I'm going to say that at the beginning. Please share it out. Like it. You know, hit the all, do the all YouTube thing. Share this out. Like, share, subscribe, share, right? Ain't that what we always say? Well, we were taught that, weren't we? In school, right? Or even at home. Gotta share. Gotta share. You bring enough for the class? Gotta share. Anyway, and thank you to everybody that gifted memberships the last stream. That was awesome. Thank you, Deep Quake, AA Ron, and I think Genius gifted some. And if I missed somebody, I apologize. And thanks for everybody that's, you know, renewing their memberships, you know, each month. I got some pretty cool stuff planned for that too. I'm thinking about, I'll just throw this out here right at the beginning, just so we'll get it over with, and I won't talk about it no more. What do you guys think about, like, maybe doing a, how can I word this? I don't want to make it like, I don't want it to be a competition. But I would, like, say maybe we get, I don't know, so we get 5,000 views on a video. If we do that, the next stream I do, I'll gift a membership to somebody. Now, I won't be able to choose who gets it. It's just whoever's most active in the chat is who the algorithm will give it to. But if we start getting 5,000 views on videos and stuff, I definitely will do that. That is much appreciated. Hey, Samantha, what's up? Thank you. Thank you. She's a member for 2 months, baby. Heck yeah. Kool-aid Krew, all up in it. All up in it. Thank you for that message. I really appreciate your membership. I really do. Okay, guys, so let's get into this. I'm really trying to cut down my intro time. 3 minutes, that ain't bad. That ain't bad at all. I'll take that all day long. Okay, because I know I just sit here and just start chiming in, and people just do, yeah, they get mad at me. Okay, to explain what happened yesterday, guys, yeah, the remnants of Beryl come right up through where I live. Okay, it was a mess here. Hey, thank you, Vicky. Awesome. She's a member for 3. Thank you for just being here. Without you guys, I wouldn't be here, obviously. I mean, I hope you guys really do realize that, and that's really how I feel. But anyway, thank you. Now, yeah, that thing came right up through here. And as a matter of fact, I wasn't really going to pull this up, but I think I will now. Because it's just going to help me show it to you guys. If you guys have never been over here to track the tropics, you guys you're doing yourself a disservice. You really should get over here. Look at this. It's a hub for just about any kind of tropical weather model, radars, forecasts. I mean, they got everything here. The GOES satellites, the ones that let me show it to you. This right here, that comes from a GOES satellite. GOES 16. But you know what else GOES 16 does? See, this is what, these satellites aren't up there just taking one image, guys. These satellites are up there doing a whole lot of things. This same satellite is, let me show it to you. Right here. See this? It's doing that too. So, yeah, that's GOES East. Now, I think this is on GOES 16. It could, or they might have moved it to GOES 18, but anyway, these satellites are pulling double duties, man. I mean, triple, quadruple. So they're up there doing their thing. So I just wanted to give you guys a little reference there. But if you guys don't know about Track the Tropics, please go check them out. I mean, really, honestly, if you come here, you end up going to all these other websites that people point you to, right? So if you come here, they're already here. It's just a big hub. But anyway, so if we go to the tracker, That's a 7-day tropical outlook. I want to go one to kind of give us a history of the full track so I can show it to you. But I think most of you guys probably already know how this thing tracked. I mean, it did. It was kind of a normal hurricane track. I'll just say that. It was pretty standard for a track of a hurricane. You know, a lot of times we see them get out there and they start doing little loop-de-loops and stuff. This one didn't do that. The steering currents for this thing just really brought it in almost like a normal thing. So yeah, where is that tracker at? Sorry guys if that's making you sick. I'm not trying to go too fast here. I'm just trying to find the one that I want. Anyway, you guys know where the track is. Let's do this. How about here? 7-day tropical outlook. This is, yeah, NOAA. So, they're actually talking about one there, maybe developing, 10% chance. But here's Beryl right now. Okay? Now, it came right down through there. Once it got on land, the upper air jet, I can't even talk today. The upper jet actually grabbed it and just really kind of whipped it out of here, right? It's here now, but it's dropping big-time tornadoes in New York. And it dropped big-time tornadoes just to the south of me. I'm talking like close, okay? To the point where people were getting freaked out. And now, I will say this. I've never seen a hurricane come on land that produced so many PDS tornadoes. Now, PDS is a particularly dangerous situation. It's like the highest warning you can give for a tornado. That means there's a CC drop on it, and what that means, the radar is actually picking up debris. The radar is able, for big time stuff that's going on, they look at the CC model. And if it shows, like, they're usually blues, the color they usually use in those. If it's picking up that color, they know that that's not rain. They know it's not wind. They know it's debris. So, I'll just say that. That is crazy they can even do that. But that's, there was so many PDS tornadoes with this thing. I think the average per year the states get was like 5 to 10. You know, we're talking big time tornadoes, guys. I mean, this is, and I could be wrong on that number, but I just don't ever remember seeing that many PDS tornadoes with a hurricane like that. And to give you a contrast for that, typically they're little spin ups in a hurricane. There's tornadoes all over hurricanes almost every time they hit land, right? But they're short lived, and they just don't, tend to get very strong because they're short-lived. So these PDS tornadoes got on the ground and stayed on the ground. And that's why they got to be the strength that they did. So, a whole lot of other reasons. But I just wanted to point that out. But just to the south of me, we had all that going on. Had a lot of power flashing and stuff going on. So I just couldn't do anything. I was dead in the water, guys. Matter of fact, there was a point in time where the power was just flicking on and off. And it was still even doing it this morning. And the storms were already out of here. So my guess is they were fixing things, doing the little reset action. But that's why I didn't do it yesterday. So anyway, I just want to give you a little explanation on why I wasn't here yesterday. That's why. So let's do this. Let me go ahead and I'm going to X out of that. Now, guys, we do have some space weather coming. Okay. Now I'm going to show you this right here. X-ray flux. What is that? X-ray flux is how we measure flares. Flares are flares, right? Now, I always talk about the baseline here, right? During solar minimum, our baseline X-ray production usually is down here in the A range. You see where it's sitting at right now? So if we're down here in the A range during solar minimum and we get a flare and it goes up to a C, that's big time space weather news because that's such a big jump in what we see. It's probably a decent sized flare. It caused that. Okay, because usually when we get flares during solar minimum, a lot of times there's just one sunspot facing us. Right now, that's not the case. We're getting 10 to 15 facing us every day. And they're continuously pumping out X-ray. So that's why. But our ambient conditions is kind of what I call it, where we're sitting at, our baseline, is already in the C-class range. So it doesn't take too much more X-ray or a little bit burst in a flare to get us into M class. Now that's the threshold that most of us look at for one reason, because that is where we start seeing issues. Okay, as far as radio blackouts and things like that, big time stuff can start happening once you start getting into M class flare range. Also, we tend to get more CMEs when we see that getting way up there. Okay, now geomagnetic activity is just nothing going on right this second. We've been really quiet. There hasn't been a whole lot of CME action happening at all. Yesterday, I don't think I've seen any. We do have a sun diver coming at diving into the sun, and I'll show it to you here in a minute. But I want to point this out. Look at this. This right here is directly facing us. It's now flaring. That's what's different. If you guys remember my last live stream, I took the time to explain to you guys the red and blue difference. Come on. Here, I'll tell you what I'll do. Let's do this first. Let's do this the right way if we're going to do it at all. Ain't that right, Wages? Okay, so we got this. This is where SDO is. This is that satellite. It's in geosynchronistic orbit. It stays right here over our planet at all times. That's what geosynchronicity means. It stays right over the same part of our planet. It orbits the Earth at the same speed that the Earth rotates. Okay? That's why it's able to do that. Now, but it always, you see it pivoting itself right there? That's what this satellite's doing. That's so it can keep its eye on the sun. See where the sun is over here? See what it's doing? And this is where it's I believe that's where White Sands is where the data is being collected. Okay? So, you ever wondered what that was. And there's a couple more models here you can look at. But it's all the same satellite. So, with that being said, let me take you over here to this one. And this is where these images are coming from, guys. Okay? So, I showed you guys this one. The magnetogram colorized version. Okay? It's going to take a second to load. While it's doing that, I'm going to take you over here to Seeds. I want to show you something. Seeds is on a different satellite. It's on SOHO. And this satellite tends to pick up a lot of sun divers, right? So this satellite's right out in front of us, about 1 million miles closer to the sun than what we are. It's orbiting the Earth, right? But it stays in that same position right there. And here in the next week or two, I'm probably going to start explaining to you guys what Lagrange points are, because I get a lot of questions on why they put satellites where they put them. And Lagrange points helps explain that. They usually just use the letter L. They'll say it's in L1 position, L2, 4, 5, that kind of thing. But I'll go more in detail on that in a different video. But as you can see here, guys, look. This right here, whenever there's a CME, that's what this tool is used for, okay? This is supposed to be there to catch CMEs. So when it detects a CME, it'll highlight it either in red, yellow, I think, or orange. There's 3 colors right here, right? And the wider it gets, the different colors start changing, right? So if you got a fan of up to 60 degrees, 0 to 60, that range, it's going to be here in black, which means most likely it's not that big of a deal. You start seeing this second color here at 60 to 120. Then you get greater than 120. Greater than 120, those typically don't happen unless it's a big filament or a really good sized CME. Okay? So just keep that in mind. But look here. None of these are lit up at all. The last one we had was at the turn of the day yesterday. And it was this one. Not much of anything, guys. Okay? Was that yet? That was on, yeah. That was on the 8th going into the 9th. So we're almost 2 days from that, almost. Okay? So if I come back up here, and I'll take you guys back here. Let's just go through a couple days here. And you're not seeing a whole lot of anything, are you? There's not been many eruptions at all. We did have some going off the backside. Okay? Here's the 8th. We'll look at this for a second. Not a whole lot happened here either. You see that little one there and then there? Then we'll get into the 9th. Okay, and I think I showed you guys this one. I'm going to stop. Yeah, because I remember stopping it and showing you this. Because what that was energy poking around that occulter disk. That's a physical disk on the camera, okay? So when you see energy poking around it, if it's a full halo is what they call it, right? It's because it looks like a halo on this disk around the edge. Remember, the surface of the sun's represented over here with the white circle. And it is a physical disk, guys, so we can't get around it. Now, some of the stereo A images, you'll actually be able to see the arm that holds it. And I've explained that before, too. But they call these halo CMEs for no other reason than it visually looks like a halo around this occulter disk. Now, this is what I call a partial halo. Not just me, everybody calls it that. But you can kind of see it poking out there. Now, I'm not sure this one here, I don't think this one's going to get us, right? But we did have one. Let's go here to the 10th, and this is where the sun diver shows up, I believe. Yep. Right about there, wink. Big game show host, baby. I'm going to pause it here. Okay, so, yeah. So there's another sun diver here. Now, there's no doubt in my mind that the sun just ate that sucker up. I mean, there's just nothing there. Now, I cannot tell you how close this is to the sun for one reason. We do not have a side view of this. Okay, we used to have stereo A out here. Now, judging by what I've seen in the past, this is way, you know, and it is starting to curve. You can see it. It's not going to curve before it gets to the sun. In other words, it's not going to come between us and the sun. It's going to go on the backside, if anything. Okay, that's how these things work. If it doesn't go around the back like a sun graver and get flung back out, the sun eats it up and it's gone anyway. Okay, so with that being said, this is not a big deal. It's just a very cool thing, and I show them to you guys every time because I want you guys to understand how busy space is. Okay, that's just the fact of the matter. Space is busy. It is a normal thing for space to be busy. Okay, so please remember that. I fight that all the time, and it's so easy to jump on that bandwagon of, hey, you know, look at all this stuff going on, you know, and at first when you get into first seeing space weather, that's exactly how you feel because it's new to you. But once you start looking at this and you start really diving into it, you figure out that this stuff, that's a normal thing. And, you know, I think they had the satellite up here, right? SOHO. And this is the LASCO C2 tool on SOHO. So LASCO's on this satellite. It's just a suite of tools that's on the satellite. Okay? There's a whole bunch of them. But with that being said, I don't think they expected to catch as many sun divers and sun grazers as what we've caught with this thing. It's a bunch. Okay, over the years that it's been up there. But with that being said, let's go to the next day. If we got anything here on the 11th, we don't. And that's kind of what I thought. Because I think what we're going to see get us, and I think it might be, because the timing's just not lining up for me right here. Let me show you why. So let me back this up. But, so yeah. So let's back that up to there. And let's watch this CME pop off. Did I go back far enough? Nope. I'll just start it. Let's just do it that way. Would have been faster, huh? I'm not even on the right day. Come on, guys. Give me a check. I'm not even on the right day. Say wages. What are you doing, dummy? See? Now, I did see something there, but I'm not... I don't know. I seen kind of like a secondary energy. You see this right here? Can you guys see that? You probably can. Now, I can't say if that went off the backside or if it came at us. I can say that this one did come on the front side, I believe. Some of it. If not all of it. I think all of it did. But we may catch a glancing blow from that, but it's not going to be that big of a deal. So I'm not even concerned about that. Yeah, you definitely can see another eruption right there. Now, I know you guys might not be able to see it. I get it. Okay? But if you watch these things like I do, yeah, you're going to notice. See how it's all, and then also that. Do you see that right there? Okay, so we get all these images on the difference imaging, right? And see how it's just kind of normal? And then all of a sudden you get that. See how it got bright? Okay, sometimes that's a flare. So when I see that, I always stop and look. So if I keep going forward, and then you start seeing this energy pop around here too. So, but I don't think any of that's really coming at us directly. So I'm not gonna. I just wanted to show that to you, just to give you guys an update on where that's at. Now, with that being said, I will show you this. Okay, this is NOAA's space weather prediction. This is the NOAA space weather prediction site. I show you guys this every time. I usually start with it, but this is a top-down view. Okay, and we're looking at density here on the top. Now the green line is the conditions at Earth. Red line, stereo A. Okay, that's stereo A, right? Okay. So with that being said, it gives us a reference, so I'm going to pause it. Now, what this does is it takes you from now and then gives you 2 days historic data behind us, right? You can see when this was updated. It was updated, this was created 11:58 UTC on the 9th. So roughly about halfway right here. And that, you know, if you see 2 days behind it, that's where that was. That's when this was created. So that means that CME it picked up right there, most likely it had to be before that. So what I'm saying is, we'll back this up. That's when this was created. Now they will change this, but this date will change too. So as you can see, when this was created, that hadn't blown off yet, because I do think that they go back a little bit. I'm not going to get too much in the weeds there, but watch what happens here. Okay, so that fires off. Now this is a side cut, so that gives us the ability to see if it's going to go north or south of us also. But you can see this one right there. Now I do believe that it is, oops, come on. I do believe that it is, oh, that's on the 20, that's on the 8th. Huh. Wonder where that's coming from. So let's go back, let's check this one out. Oops. That's his data. Huh. That is kind of strange. Let me go up here to the 9th. Let's look at the 9th, because that's when they're saying that popped. Now, yeah, there it is. Okay, that makes sense. There it is. That's the one I showed you guys. It just wasn't showing up in the detector. It didn't really detect a big time CME. That's why it wasn't showing up on the bottom. That makes sense. Okay, now I feel a little bit better about that. Let me see this too. I seen something here on the end. Yeah, you had another eruption there. You had some there. Some of those were off, you know, off the backside. But it does look like that might be impacting us. Okay. So, oops. Let's go back to here. Right. So there you go. Right there. That's the CME. So this gives us the ability to see east-west, the top-down view, and then north-south on the side cut. Now down here is velocity. We're going to just take a look at the density. So this is when it started, right? You don't see anything really at all right there. But then, boom, it happens right away, right? So they're saying that this thing should be hitting us close to the turn of the day on the 14th. Okay? So we're looking at 3-4 days, if the timing's correct. Also, this is not a direct hit. Please keep that in mind. This is going to be nothing more than a grazer here. Okay? Hey, miss, what's going on? Butterfly, what's up? What's up, Wrath? What's up, George? Mark, what's happening? K-Heads, what's happening? George is in the hizzy. See, hear, think. See, hear, think, baby. All right. So that is what we're going to be looking at as far as the CME. Now, with that being said, I want us to keep in mind this thing. Okay? We can't let our guard down on this kind of stuff. And for one reason, this thing was over here, and it was just about the same size. It is a little bigger than what it was, but now it's becoming complex. You guys remember what I said makes it complex? When the magnetic cores start swirling with each other. So when the sun flares, it's basically a reconnection of positive and negative magnetism, and it causes that, kind of like a short, okay? So when you start seeing the reds and blues mix, that's positive and negative. So the closer they get, the more they mix, the more chance they have of flaring. And this one's right in front of us right now. Now, I will say this too, and I don't say this for any other reason, but this is just what it was. The one that gave us the big G5 storm back in May did the same exact thing. Okay? If you guys go back and look at my live streams during that time frame before that storm happened, I started talking about it when it was over here. And it basically, when it was here, it wasn't that big of a deal. I even said that live. And I said, hey, this thing it's grown a little bit, but right now nothing to worry about, right? Well, in like a day or two, the sucker just blew up and started flaring. And then when it got over here is when it sent us the ones that gave us basically the G5 storm. A whole lot of things were going on during all that too. But this resembles that same sunspot. Now, is it going to do the same thing? I am not saying that. Not at all. Not even close. Okay? I'm not even close to saying that. So just understand that it's a possibility. Anytime these things happen, it's a possibility. So I would just say that. Yeah. Yeah. Okay. Now, guys, give me a roll call in there. It helps the algorithm too. I like to see where you guys are at on this planet. Susie Q, K-Heads, Wrath. And guys, yeah, hey Gunslinger, what's up? Carol, what's happening? Guys, listen. This is a really slow time for YouTube, okay? So anything you guys can do as far as sharing it out, it really does help. And I'm not just saying that for me. I'm saying it for every other channel that you guys watch and support and really like. It really does help, and it only takes a couple seconds to do it. It truly does. And again, if you guys go look at anybody's YouTube channel right now, 90% of them probably their views are down, and it's because it's summertime. I get it, right? And I'm not complaining. I'm not just saying that, but the only way to kind of offset that is to do those kinds of things. And you know, like I said, guys, if we can get to where I'm getting 5,000-6,000 views consistently on a video, and I know I'll get there. I mean, I love you guys too much. I know you guys support me in a very good way. And, you know, eventually we'll get there. And I'm going to make it happen. I'm not just going to sit here and just wait for it. I'm going after it. But anyway, please do that for me if you guys could. Just share it, like it, that kind of thing. But if we get 5,000 views in a few videos in a row, I'll start gifting memberships if I think that's a good way to give back to you guys. And don't forget, I got discontinued playing cards, Sunspot playing cards. My wife found them online. I give those away. Ilea and Deepquake got some. Who else? Shoot, I can't remember who all won those at this time, but they all got them. They all loved them. They're really cool. But anyway, I just wanted to point that out. East Tennessee, baby. Lake Wenatchee, Lebanon, Indiana, Virginia, fellow Hoosier, baby. Michigan, Central Pennsylvania, Crystal River, Florida. Wow. I bet it's hot down there, isn't it? Man, I walked out before that hurricane came up through here the day before. It was like walking out there in a big old ball of humidity, man. It was bad. So, anyway, let me get this going here. 304. This is ionized helium. Okay? Again, this is on SDO. It's extreme ultraviolet. They could give this any color they want. Alright? You're going to notice right here, this one's going to start doing stuff. This is that sunspot. See it crackling now? Okay? Now, if we start seeing some big time stuff here, I'm definitely going to be coming out here showing you. Irwin, Tennessee. Angels win. What's up, Angel? Gambling is idea lost profits, literally. There you go, Daniel. Oh, man. It's like a sauna? Yeah. Really? That's interesting, Gunslinger. We're going to have a conversation about that. I love talking about that stuff. He says he worked at a nuke plant there in Crystal, was it Crystal River? Yeah. That's interesting, man. That's a pretty cool job to have, I would think. Now, I'm going to show you guys a couple things here, okay? So you got a dark shadow right here, right? That's a filament. It does look like it's starting to lift off, and it did eject a little bit right there. And it's hard to see because the sun's the background. It's camouflaging it. It ain't the background of space, but watch right here. See that little puff? And, you know, those little things, some of those can be stealth CMEs. It's exactly what you think it is. We just didn't see it. It's stealthy, right? But I seen something on the end of this run. Okay, did you see that one? But watch this. Watch right here on the end. Okay, did you see that? And then the time stopped, right? So I'll take it to the end here. Look, that is a CME. Okay, and it looked kind of like a filament. So that's going to be ejecting off to our north. Looks like it's mainly on the backside there a little bit. So most likely that thing's not going to affect us whatsoever. But I wanted to point that out to you because that is a CME that's lifting off the sun as we speak. Okay. But you can see these other ones too. They're still active. This is that big sunspot. Now, let me show you guys one more angstrom of this and then we'll move on. I do want to show you, there's a 211. This is the one I use to show you guys coronal holes. Coronal holes is exactly what it sounds like. It's a hole in the corona of the sun, which is the atmosphere. So why is the hole black? It's not a hole in the sun. It's black because the surface of the sun is colder than the corona, its atmosphere. And they're still trying to figure out exactly why that is. They got some pretty good ideas, but yeah. But also keep in mind, guys, this thing is right in front of us right now. And this is going to give us, and I would be on the lookout. Well, we've already had big earthquakes. So anybody in earthquake zones right now, pay attention. When these coronal holes open up right in front of us and we connect to them, the chances of earthquakes go up significantly. Okay? Any kind of seismic activity, volcanoes, all that stuff, right? And it's a proven thing now. It just does. There's no question. I'm not sure exactly what the percentage is, but it happens. So keep that in mind. Also, this is going to be sending out fast solar wind, probably more dense. How long does it take to get here? Depends on how fast it's moving, obviously. But typically 2, 3, 4 days. Something like in between 2 to 5 days is what I would say, depending on how fast it is. But we definitely we're connected to that. It's right in front of us in the Earth strike zone. It's been a while since I've been able to show you a coronal hole in that kind of a direct position. And these can, and they do, and this one may, it probably will, instigate a geomagnetic storm. Especially if we got anything else hitting before that. But you can kind of see little puffs around here on this one too. Now there was one here right at the beginning. Watch this over here. Watch here in the corona. See that? That was an eruption back there on the backside. So those are the things that we can see, and that's why we look at different angstroms. Okay, we see different gases, and it gives us different points of view. Okay, now I'm going to say something here at the risk of being completely wrong. Okay, this is the geoelectric field model. Now I've been watching this for about a half hour, right? And there's some activity going on. I'm not really quite sure why. Maybe we're getting hit with one of those stealth CMEs, but I can confidently tell you that this is not a ambient looking map. Okay, typically this thing will be blue, light blue everywhere. So when you start seeing these colors pop up, that means we're having some sort of activity. Now, this is geoelectric, not geomagnetism. Now, geoelectric is directly affected by geomagnetism. That's why we look at it. They use this now. They're trying to bridge that gap between earthquake forecasting and space weather and how space weather affects it. But do you guys see what's happening here? We're taking some sort of geomagnetic hit. I guarantee it. Now, it's not a big hit. We may not get into storm level. I have no idea. I didn't think anything was happening today when it comes to that. I didn't see anything. But you see that little blast right there. Now, that could be anything. That could have been a flare or just a little tap from a CME, that kind of thing. But it does look as though, and I'm going to stop this right here. You know, it does look, because it's hanging on here for a few minutes now. So, right there, you see that? So, whatever that was, I can't tell you for sure. What time did that happen? Where is the timestamp? Right here. That happened at 15:55 UTC. If you're on the East Coast, that would have been 11:55. So almost noon. Noon East Coast time. Eastern Standard Time. Okay? But you go from that, which is normal. See? Not much going on. And then boom. So, yeah. And then the rest of the day, it kind of stayed a little active there. And I get questions a lot. Why does it show up in other certain areas? You're going to notice that there's a better chance of seeing more activity around higher populated areas because there's more electrical components, guys. This is showing you space weather's effect on artificial electrical components. That's what it's doing. So anything artificial, light switches, transformers, wires, your flashlight, I mean, anything electric. So that's active right now. Now, so what we'll do is we'll come here to the geomagnetic model, Geomagnetosphere. Geomagnetosphere. What am I saying? It's the magnetosphere. Sorry. But yeah. So this is velocity here on the top. This is density. Okay. And then down here, this is magnetic pressure. And people say, why does it say geo? Okay. Well, if you guys look that back and you go to the root word of things, like we used to in like Latin languages and things, geo is, whenever you see that word geo prefacing any other word, it's talking about Earth. You can almost replace that word geo with the word Earth. Now, yeah. So, now when we're talking about the sun, that word is helio. Okay, so when you hear heliosphere, because there is a heliosphere, we have a magnetosphere, right? The sun has a heliosphere that actually extends out and protects the whole solar system. Us included, from stuff coming from outside of our solar system coming in. All right, so always keep that in mind. That's what's happening. Hey, Verte, good to see you, brother. I've seen you in a minute. Rest in peace, Mike. Mike who? I missed something? Hey, Vicky. Really, Vicky? Wow. You guys need to read that comment. She says, hubby and I driving down the road saw a flash from a power line, then smoke. So weird. Yeah. That's kind of weird. Yeah, well, you know. Hey, and also, guys, we got to still pray for the hurricane victims. I'm telling you. And then all the tornadoes after that. Oh, my gosh. It's been a mess, guys. It really has. It's been bad. It really was. For a Category 1 hurricane to do what it did is crazy to me. It just is. It's crazy to me. The tornadoes, I think, probably did more than anything almost. But anyway, this is density, right? Okay? The lighter colors, the white color is lower density, and then the darker blues are higher dense. So if I grab this is velocity, and you can see right there, you see that right there? That's something that's hitting us there. Now, it's nothing big or huge, but we are seeing some increased activity there. So, well, how do we kind of prove any of that out? Well, one thing we can do is come over here to Discover. This is the actual space weather data. I try not to show this too much because it's just boring to look at a graph. Sorry, just is. I don't find it boring because this is what I do, right? But I get it. So the top up here, the BZ is the red line. That's our magnetic positioning, basically. We look for a threshold of -6. That's the red line only, okay? When we get to a -6, that's when we're really in a magnetic position to really accept some of the space weather coming in. It gets in easier, okay? I'll just use that kind of terminology. And we could get technical, and I could start throwing you a whole bunch of word salad. But I promise you, nobody wants to do that. Yeah, anyway. But, -6, when you see -6 in that little box up there, okay? That means we're in a position now ready to really take a good hit, right? So we're not there. We didn't get to -6 yet, but you see how the BZ's diving right now? Now, also the reverse is true. If it's in the positive, it'll deflect it more, I should say. The sun can give us a blast of any size, and it can still get through no matter what. No matter where that magnetic position is, okay? If it's a big enough blast, it's getting through. But I'm just saying, we tend to see higher storms happen when we're -6 and more, okay? The phi angle here, that second box here, where'd my cursor go? There it is. That's the actual polarity of the solar wind itself. When that thing flips back and forth, and it does often, look at it. Sometimes when it flips, it can jerk on us hard enough that it can actually put us into a geomagnetic storm for a short amount of time. And we really don't even know when that's going to happen. It just does it. So, and I'm sure there's some indicators, but I just don't know what they are. Anyway, this is density, okay? The orange, nothing out of the ordinary. There's nothing out of the ordinary with the speed. The only thing I'm seeing is that everything is reacting right now. You see that? When that happens, that typically means we're having some sort of activity. It's nothing big. I just wanted to point that out. Okay, now. Oh, wow. I didn't read this first article. Dr. Tony Phillips over here at spaceweather.com. Watch this movie, he says. I'm not going to watch it. Please go over here at spaceweather.com and give him some traffic, guys. That's how he makes his living, okay? So please, I've never even talked to Dr. Tony Phillips. I just think he has a great website. And I think it's awesome. So please do. His link is in my description box. If one of my mods wants to put that in there, you're more than welcome. But anyway, this is a comment. I would, guys, please go over here and read this article. This comment, they're talking about maybe getting ready just to freaking be gone. So is this comet doomed? It says it's falling apart. And they're seeing some evidence of it. And I'm not going to go read the article because I want you guys to do it over there. And they're talking about comparing images here and there and everywhere, right? So, I'm not going to go into detail here, but please go over here and show him some love with this. Also, something I haven't been talking about a whole lot, and I used to talk about them quite a bit. I need to quit with that stupid mouse. Okay, so I used to talk about noctilucent clouds a lot. Okay, there was a different map that they used, different graphics, and the satellite they were using, I guess it doesn't work anymore. They had some issues with it. But what causes noctilucent clouds, and what are they? Noctilucent clouds are blue metallic looking clouds. And sometimes they're really hard to see. Okay? They don't tend to live next to the equator, okay? They actually happen in the summertime of each pole, okay? So in summertime right now, the northern hemisphere, we should be seeing noctilucent clouds. We're in that season. And if you think about it, it's almost like, well, that shouldn't be happening, because a noctilucent cloud is water vapor that freezes around meteor dust. Okay? That's what makes these things. So you hear that word freeze, you don't go straight to summer. That ain't where your brain goes, right? Well, the reason why is the ionosphere is cold anyway, right? So that's what's happening. The water vapor is melting, basically. We get some glacier melt, or even just over the ocean water. More vapor is being produced, so it goes up, and it gets up into the ionosphere, and we see noctilucent clouds. That's why it's in the summertime. Okay? Now, when you start seeing them closer and closer to the equator, that means things are a little different than what they usually are. It's a good indicator of stuff. And again, it's not a huge deal, but it is one of the indicators we can look at, right? So I just wanted to point that out. And we'll talk more about those in a different video, guys. I don't want to spend too much time on that. Okay, guys, and again here, this is the near-Earth object graph. Go over here and check this out. This will show you, they measure, when they're looking at meteors, it's lunar distance. The distance between us and the moon. That's how they measure things. That's a unit of measurement that they use. Now, if you ever hear that word astronomical unit, that's the distance between us and the sun, which is roughly 93 million miles away. That's that unit of measurement. So keep that in mind. Now, oftentimes you'll come over here and you'll see something that'll say 0.4, right? And you're thinking, oh my gosh, it's going to hit the moon. No, this means it's coming between the distance that it is away from the Earth is inside the orbit of the moon. Okay? So, I hope you guys can kind of understand that. It's, in other words, that meteor came closer to us than the moon is. That's what that means. Okay? And I'm not seeing any of that right here. right now. But a lot of times you'll see them. And this is the year they're discovered. 2024. Most of these are discovered in the same year. And believe it or not, guys, some of these are discovered after they pass us. So keep that in mind too. But the ones that we typically miss are the really small ones. We're not going to miss big ones, obviously. But the smaller ones, medium-sized ones, we can miss those, right? And like Billy Bob Thornton said in the movie Armageddon, begging your pardon, Mr. President, it's a big-ass sky, right? Ain't that what he said? And that's so true. It really is. Because they were asking, how could we miss this asteroid and all that, right? It's a big sky, guys. Sorry. It just is. I like the old Roadrunner thrust maneuver. I love that line in that movie. Anyway. Okay. So, guys, I don't have much more. I will be coming back in the morning to give you guys a update. Yesterday I was not able to do it. I had so much stuff going on. I was afraid to plug my computers in, just to say. I'm just being honest. Because stuff was just too crazy. And it wasn't really like crazy right where I'm living. Okay? It really wasn't. Because I don't have any trees down in my neighborhood. I don't have none of that stuff. Right? It's just when you're talking about like grid stuff going, having issues, it doesn't have to be right where you're at. And the power was flashing, and I don't take chances when that stuff's going on. I tell you what I do need to do, though. I need to start learning how to live stream from my phone in case I need to use 5G. I'll probably work on that this week sometime. But anyway, I will be back tomorrow, guys. And I guess the draw from this video here, guys, the kind of the conclusion here, this week we got to pay attention, okay? Because of this right here. This sunspot right here and this coronal hole. This sunspot's starting to become very, very active because it's becoming more and more unstable, more complex. Positive and negative are swirling with each other, and it's going to be flaring. So, that's just what I'll say. Alright, guys. So, I'm going to go ahead and get off here. God bless. Yahusha saves. And, yeah. As always, you can drink this Kool-Aid.